Hi, I am Madhav. In this video, I am going to talk about the design of the CPU and how it is implemented in a HDL code. This diagram is the proposed design for the CPU architecture. In the following diagram, the CPU consists of several logic gates such as the ALU, A register, D register, program counter, and multiplexer. Since we have built most of these logic gates in the previous task, so it is quite handy to implement the code. So there are three inputs coming into the CPU and four output pins coming out from the CPU. So these three input pins are instruction memory and data memory. The instructions are in M and reset, and four output pins are out M, write M, address M, and program PC, program counter. So the the three output pins which is coming out from the CPU, it they have their own function. One is used to read, another one is used to write, and one enables writing. So let us understand the header section that specifies the CPU interface. It consists of the chip name and its name of its input and output pins. Since we are implementing the CPU chip, the chip name we are going to write is CPU. So let us understand the code line by line. So first we take NOT gate, AND gate, and MUX16 gate together. These gates allows the CPU to function and perform specific operation. Firstly, there are two types of instruction coming into the CPU from the instruction memory. These instructions are A instruction and C instruction. So NOT gate is used here to determine the A instruction. If the instruction coming into a CPU from an ROM is A instruction, then CPU takes the specified 15-bit value and stores the value into the A register. Another NOT gate is used to determine the instruction is an C instruction. If it is an C instruction, then it performs the computation and the ALU output is fed to the A register. AND gate is used to store the C instruction, and MUX16, which is 16-bit multiplexer, is also used to select whether the instruction or the ALU output is stored in the register A. So let us see another OR gate A register, OR gate and A register. So A register, what A register will do, it will take the output A regin from the 16-bit multiplexer, A register in from the 16-bit multiplexer, and it will take the output load A from the OR gate. So what does A register do now? It outputs A out that generates the value that is currently stored inside the register. So we have used another MUX16 gate that takes in the output of the A register and the value that is currently selected in the data memory register in M. Now the output load D is used by D register. It stores the value of the D register from the ALU. So uh, there are few lines of code from the ALU. So first of all we can complete first of all we can go through the ALU diagram part. So it consists of 6 input pins and 2 output pins. So it computes a function on 2 inputs, which in this case would be in the value that is stored in D register and the value of either the A or M register, which generates the output. So another piece of code. Now the following code consists of two OR 16 gate and an AND gate, which sets the ALU output in order to successfully write on the data memory. The first OR 16 gate is used to determine the address of the write operation. The another OR 16 gate is used to determine the content of the data memory, and the AND gate is used to output a value that allows CPUs to write the content on the data memory. So there are next next few lines of code. So these lines of code determine jump conditions and check the ALU output to see if the condition is met. Like it will jump if this is get, if it's zero, if it's non-negative, if it is greater than. So all these piece lines of code we have write in the last section. So one important thing is that CPU will read the instruction only and only when the program counter is not loaded. If the program counter is loaded, then the CPU will not read the next instruction. So in this way I have implemented the code for the hack CPU. I hope you like the video. I was a bit shaky, but this happens. So yeah.